Good morning, class, uh, and good afternoon. So, as we wrapped up chapter five with electron configurations and the pretty much overall idea of where electrons are located in an element or an atom, we're going into the periodic trends or the kind of like how that periodic table is organized. Um, the periodic table is organized by atomic number, although the elements show certain characteristics as they're lined up in their periodic table. Um, because of their arrangement of their electrons, they have certain properties, and this PowerPoint is going to go over each of those individual characteristics and why is it that these periodic elements are aligned the way they are. So the essential question for you guys today is organizing, or how is the modern periodic table organized? Um, like I mentioned, it's organized in a certain way. And our objective today is to understand, ask questions, and clarify anything that we may have questions on about this. So here we go. So Dmitry Mendeleev is the initial scientist or researcher that is the credit holder for devising a periodic table. He was the first person that was to organize the table as the atomic masses increased. So you may notice that it still has this certain characteristic today, although there may be certain elements that are sooner in the number of elements, but have a higher atomic mass. Just know that he's the one that was the first to organize the periodic table and increasing by increasing atomic mass. Um, so he also understood that there were certain elements that were not discovered yet. So you understand that in 1870, they didn't have a grasp or didn't have the technology, didn't have any idea that there were other elements in our universe. By that time, science was booming, technology was lacking. There were so many questions that were left unanswered that there was nothing that they could do about it because of their inability to research, to perform tests like we can today. So, Mr. Henry Moseley is the person responsible for ordering the elements in increasing atomic number. So, in Mendeleev periodic table, he had no idea about the atomic number of the atoms. And by the time Moseley was a part of the research, he was able to discover that their elements had a certain atomic number or a certain amount of protons, and that's how they are organized today. So I kind of already went about this so far. Excuse me. The properties of every element are repeated on each row. So that means that all of these elements share the same properties. All of these elements share the same properties, and so on and so forth. Okay. Um, for example, this entire row right here is considered the noble gases in chemistry, and they all share one important characteristic. They are all gases. They all have eight electrons in their valence orbital shell, and they're happy. They're a gas. They have eight electrons. Remember the magic number eight, and they're stable. They are enjoying life, except this little guy right here. This is helium. But remember, the first energy level has two electrons. Oh, look at the helium. He only needs two electrons. So he's stable. He's happy. he has the same characteristics as these other noble gases. So periods are essentially just the rows. So periods are just how the elements are aligned in a horizontal row fashion. So when I say periods, it means rows, or when I say groups, it means a vertical column. Remember on the periodic table in our textbooks, we have 1A, 2A, 3A, 4A, 5A, 6A, 7A. Those are groups. So there's group 1A, group 2A, group 3A, 4A, so on and so forth. Remember, those 1A, 2As are describing the number of valence electrons in those groups. Okay, so all the elements in this group 7A column have 7 valence electrons. Okay, very important when we start researching, or not researching, but start going over the covalent bonding and all the bonding of electrons. Okay, so let's keep going. So typically the metals are located on the left side of the periodic table, which are right here. These two groups or columns of elements are metals. Okay, one has a certain feature than the others. Although both of them typically are shiny, they can pull into wire, so they're ductile, meaning that they're very moldable. You could shape them in any way, and they are malleable, like I mentioned. And they're good conductors of electricity and heat, which means that if you are to put your a metal pot onto a stove, doesn't it get hot right away? Compared to say you put a blanket over like something hot, it's hard to. That's such a terrible example. I apologize. Just think of it as a good conductor, meaning that heat and electricity passes through the material easily, so easily. Okay, so like again, like when you put a pot on a stove, a steel pot, which is metal, notice how that right away the heat goes through the bottom of the pot and is able to cook whatever is in the pot. So just understand what that means by good conductor. Alrighty. So on the right side of the periodic table, over here, they are our nonmetals. Okay. Typically, they're good insulators, so they're able to withstand and keep in heat. And they're normally glasses or very, very brittle solids. Okay. So they could be still a solid, but not be a metal. And that's what these are. Okay. So neon, an example, is a gas. So you see those very bright, colorful signs in restaurants, old restaurants, bars, and stuff like that. That's an example of neon. That neon gas is what gives it that luminescent color. Looks really pretty. All of that good stuff. Sulfur. Here is that it's really smelly stuff. It's in solid form. Here's iodine in solid form as well. And here's bromine. It is a liquid. Okay? These two are examples of diatomic molecules. We'll get to that later, but just because it by itself, it's not just I, it's I subscript 2. Same thing with bromine. It's not just Br, it's Br subscript 2. Look at neon, for example. Neon doesn't need a subscript 2. That's because it is not a diatomic molecule. Okay? We'll learn about that a little bit later. And last slide of the session, metalloids. They're kind of metals, kind of not metals, okay? They are found in this little region right here, okay? And they are metalloids, okay? They are non-metals, but they're semiconductors. So like silicon and germanium, they're used for computer chips. These are elements that helped with our computer industry to develop these computer chips and be able to, further into our technology capabilities. So that is it. Please take the time to rethink of everything and have a good day.